So now we have to start the new next step in 7.5. After 7.3, we have 7.5. We don't have 7.4. Here, if you look at the title, basically it is in 8 forms. Do you have the idea which forms in maths we call intermediate?
Yes, the 7 undefined forms.
Yeah, we have 7 intermediate forms. For example,
Pi over pi, 0 over infinity over infinity,
Yeah.
0 over 0.
okay,
You have 7, 4 to the power, and 4 are the divide or minus.
yes, exactly. Basically, when you are going to, actually these infinite forms we interact during the calculation of which topic?
Limits.
Limits, yes.
Chapter 2.
So when you are going to calculate limits of the function, basically we are interacting with these forms, which is called indeterminate forms. Or in simple words, you can say undefined forms, okay? And yes, there are 7 in total. And 3 forms are basically as a power. 4 are without power and 3 are with powers, basically. Now, to handle this indeterminate forms, basically we use a technique which is called logical series. Yes. Don't have to different things. So logical rule is basically used to tackle these indeterminate forms during the calculation of limits. Okay. I will share with you these 7 forms, means how it looks like, and what is the procedure for this logical, is how logical rules work basically. So now we have 7.5, it's 7.5, which is indeterminate forms. Indeterminate forms means we cannot determine. And the procedure which we use here is called logical rule. L'Hopital's rule means the logical method. L'Hopital was a mathematician, a French mathematician. He introduced. Actually, he did not introduce. Basically, it is done by John Bernoulli. He basically discovered this topic, but first time published in the paper by this L'Hopital. That's why it goes to his name. Otherwise, the founder of this method was James Bernoulli, John Bernoulli. Okay, now, for example, you have the question related to limits, point limits, okay? And when you are finding a limit, so you know what's the procedure. First, we put substitute the value directly.
Yes.
Okay. Now, when you substitute the unique value, the point directly in the function, and if you are getting 0 by 0, this is one of the indeterminate forms, means undefined situation. And other situation is that infinity over infinity. This is also one of the infinite form. Then
Infinity minus
infinity minus infinity. This is also tackled by logical rule. Okay. Then 0 times infinity. This is also comes in this category. So these four forms are basically without power. Now there are three more forms who will become as a power. Okay, it means we know very well if you have some constant and its power is 0. How much constant power 0? How much? 1. 1. Now, if the constant is 0 and power 0, what's the answer? Now, again, it is, we cannot determine it. This is basically ambiguous case in maths. 0 power 0, yeah, is the undefined form. So means some concepts which we have done already, it is not working at all in some cases. Similarly, if you have infinity and its power 0, of course, we cannot determine. Means it is called indefinite form. And then last, of course, not least, if you have 1 and its power is how much? Infinity. So again, this is ambiguous case. We are not sure about that. So these are in total, how many forms are there? So 7. Yeah.
It's not true that anything times 0 is
What are we saying infinity?
0 times infinity.
To some extent, you can say, but mathematically it is wrong. But basically, during some calculation, we use that. Infinity times 0 is equal. But mathematics not allowed. Okay.
Faster.
Okay. Now, let's take a question, please, and try to, cover one by one these forms, please. Okay, so let's take a look. 7.5, and this is in debate forms. Right, so we can say, okay, I start with example because these examples are covering, some sort of one by one these cases. So example 1, part B, 1 plus x square root minus 1 over x. Sorry, not this one. Okay, part C, please. So we can go to this part C, please, which is. So we have example 1, and I'm taking the part C of the example 1, which is limit, yes.
When x goes to 0.
X up to 0, yeah.
And square root 1 plus x.
Square root of 1 plus x.
Minus 1.
Minus 1.
Minus x over 2.
X over.
And then the whole function over x squared.
X squared. Okay, good. Now look at here. What is the objective for this question? We need what? Limit. And at this point.
So
At 0. So we need limit at 0, please. Okay. Now, if it is the one of the 7 forms, we can use logical rule to find it. I will explain to you means how logical rules work, please. Okay, just wait. Now, first of all, we have to check. Is this question, is limit question, is following any form?
Yes.
Yes.
Substitute directly, first of all, 0. Where are your x? Substitute 0, please.
1 plus.
So 1 plus 0 is 1, 1 minus 1, 0, 0 by 2 is 0, divide by 0. So basically it is 0 by 0 form. So one thing is confirmed, this question is basically is one of the forms, understand? So it means we can use which technique? Logarithm.
Which is the derivative of the numerator over the derivative of the denominator.
Yes. So we can use here logarithm rule, and how it works? Logarithm rule says take the derivative of numerator separately. Don't use quotient rule. No, please. Only derive the numerator independently and differentiate the denominator separately, independently. This is basically logarithm rule. And then again, we put our limit value and we check the answer. Okay. So, as I explained to you, that this is 0 by 0 form, which is the required form of this L'Hopital rule. So we can apply here L'Hopital's rule, please. Okay. Now, as per the L'Hopital's rules, definition, we can differentiate now the numerator. What is 1 plus x root derivative?
X.
Half of 1 plus x times inside derivative, which is 1.
Yeah.
Okay. 1 is constant. Derivative 0. X by 2, how much derivative?
1/2.
1 over 2. That's it. Because x is 1, 1 by 2 is constant. So x by 2 derivative is 1 by 2. Clear?
Yes, but
Divide by. What is x square derivative? Oh, yes, 2x. So as per the L'Hopital's rule, we differentiate numerator separately and denominator separately. Do you understand the first step?
yes, doctor.
We basically applying L'Hopital's rule, which means differentiate upper part independently, denominator part independently. Yes, please.
But you may even get twice 0/0. So you have to
Yeah, of course, we have to again apply. Yes, yes. Okay, now we have done. Now, please again substitute x0, please. So 1 plus 0 is 1. We have 1 by 2 positive. Here 1 by 2 negative. So numerator how much? 0.
0.
And 2 times 0?
0.
So again you have got
0.
0 over 0 point.
Doctor, I have a question.
Yes, please.
What if we got like number over 0?
Number of 0?
Number over 0.
No, it's undefined. Of course.
No, but like,
Divide by 0. You cannot use the.
no, but
No.
it should be specifically 0.
Ah, exactly. Specifically 0 by 0 or specifically infinity by infinity. These are the requirements. L'Hopital's rule. Please.
So we have to check. Right?
Yes. Every time you check, match the condition of L'Hopital, apply L'Hopital. Please.
What if it's 0 over infinity or infinity over 0?
All are, undefined forms.
So do we?
If any form doesn't match here, you can apply. Use some other method. Okay, so because this is again 0 by 0 form, which is the required form of L'Hopital's. So again, you can differentiate numerator and differentiate denominator, please. Okay. For the sake of differentiation of this part, how do you differentiate this one?
1/10 and cheat it again.
Yeah, of course. We have differentiate again. We have differentiate numerator again, please. This one. 0 you can move because it's 0, no need. So we have differentiate this and this, please.
So the minus stuff is 0.
Yeah, it is okay. It's 0, finish.
Yes.
What is the derivative of half 1 plus x square root? How to differentiate?
Can I keep the half as
One,
one
yeah.
times the derivative of square root of 1 plus x, which is
One
again
over-
1 over 2 square root.
No, wait. It is square root of x. No, it is 1 over 1 plus x. Please.
Should we raise it up?
We take it up. Exactly.
Can you please question through?
No need for that. Very lengthy. Do a very simple thing. 1 plus x square root, take it up, please. So when you move it up, what happened?
Become minus.
Its power become negative, means 1 plus x is power become now negative. Exactly. So please, for the sake of differentiation, I take it up, okay? So that we can easily understand how we are differentiating now. Okay, so please start now, differentiate. 1 by 2 is constant, so it keep as it is, please. So limit x approaches to 0. Now we are differentiating this part. Well, I have already 1 by 2 with my question. Now please start power rule. And means chain rule, okay? And
Yes.
x n minus 1 minus half minus 1 minus 3 over 2 times inside derivative, which is 1. So no need to write 1. Okay, what is the derivative of 1 by 2? It is 0. So this is already 0. This is 0. No need. Okay.
Over
Divide by what is 2x derivative? 2.
No, it's not.
So 2x derivative is 2. Okay, just wait.
Why is it multiplied by 1?
Simplify. Simplify first, or I think you can apply now limits. Put now 0 here. 1 plus 0? 1. And 1 power minus 3 by 2, how much?
1.
1. Okay, so please, what is your answer finally?
Negative.
What's the answer, please? Negative 1 over?
8.
And we get the answer of limit.
Doctor, should we take it down or you just substitute and that's
Substitute is fine. But it's better to, make positive, yes. It's better to make the power positive. Okay, just for your understanding, I can simplify first and then we can evaluate the limits, please. So this is limit. X approaches to 0. 2 times is 4, so minus 1 by 4. Bring it down, 1 plus x power positive 3 by 2. This divide 2, I can change to multiply. So it becomes 1 over 2. And now you can substitute this. Same number, of course, same. Yes. I explain one more step to easy understanding, please. So 4 times 2 is 8 because when you substitute here 0, when you put here 0x, so definitely it is 1. So the answer is how much? Minus 1 by 8. So this is limiting value of this function by using logarithm rule. Did you idea this? Actually, please be careful. Here I basically skip one step because the 1 plus x square root derivative was this one. It was 1 over 2 square root of 1 plus x. Understand? Then I need further derivative. I take it up. That's why power becomes negative. Then I take the chain rule. Okay? Right. Okay, so let's go with one more question, please. It's fine. We can take the next. Right, okay. So here, example 4, please, we can take the part A, secant x divided by 1 plus 10x. Example 4, part A, please. Example 4, part A. So, sample 4 and part A. So limit is basically
Just y over
x approaches to pi by 2.
secant x over 1 plus
Secant x divided by
1 plus tan.
1 plus tangent x. Okay. So this is now question for limit, please. First of all, please substitute this x value pi by 2 directly in the question, and please check what are you getting, please. So secant, how to write, please?
1 over cosine.
Yeah, means for secant we can write 1 by cosine. 1 by cosine and divide by we have 1 plus tangent x. The x is pi by 2. So 1 over cosine pi by 2, how much? 0. And divide by 1 plus tangent pi by 2. Tangent pi by 2 is what? So 1 by 0 is what? And divide by what? So this is which case?
Infinity over
Infinity over
infinity.
infinity. This is infinity by infinity case.
But put in the exam, should I like show you which case it is?
No, it's fine. It's fine. It means if you are comfortable that is this case, we can start. It's fine. But you know which case is coming up. So please let me know if you understand. This is numerator is infinity. Denominator also infinity. Okay. So this is infinity by infinity case. Is this logical rules requirement?
Yeah.
Yes. Start differentiation. Differentiate numerator, differentiate denominator. So in your numerator, what is the function?
Secant
Secant x. What is secant derivative?
Secant tan.
Secant tan. So x approaches to pi over 2. Secant derivative is secant x tangent x. Okay. Divide by what is the derivative of 1 plus 10?
Secant square.
1 is constant, derivative 0. Don't need. What is tan direct?
Secant square.
Secant square.
And you secant.
Okay, now we can basically this and this is cancel out.
No.
So we have now this implies the limit x approaches to pi over 2. We have now 10x divide by secant x. Okay, right. Now we have to simplify first, please. 10x and secant. Secant, how write secant, please? 1 over cosine. How write tangent? Sine over cosine. So just wait. First of all, we try to simplify, please. So limit x approaches to pi by 2. Tangent I can write sine x divide by cosine x. Then divide secant I can write 1 over cosine x. Now please divide when change to multiply. 1 by cosine becomes cosine by 1. Means get flipped. It becomes here like that. Times sine x. Okay? Divide 1 cosine becomes cosine by 1. So it becomes cosine by 1. It's flipped. This and this cancel out. Now please apply limits. Apply limits means where x replaced by pi by 2. So sine pi by 2, how much? 1. Yes, right.
After we simplify because if we apply pi over 2 there x, then it gets 0 over 0.
Yeah, so it's
Can we
better.
define again?
Actually, we always try to substitute, limiting value in simplified form. So first, we always try to simplify.
But if you get an answer, it's correct.
Yeah, you get the answer, yes, correct. There's no more. You should put the value, get the answer, that's it, no problem.
And you have to keep writing limit as x tends to pi over 2.
It's okay, means if you are not writing again, no space, so you can write at the end. But of course, because it's a syntax, mathematics syntax, so it's better to keep this. So understand, it was infinity or infinity, agreed, okay? And we have the calculation. Okay, let's take the next case, please. Okay, so next case, we can take this one, please. Example 5, part B, please. Root x ln x. Root x. So we have now example 5 and part B, yes.
Limit of x approaches 0 to the right.
Limit x is approaches to 0 from right side. Here of x and ln x. Good. Right. By the way, it means I'm just asking just for the information. X is approaches to which side of 0?
Right.
Right. Why they put right side? Is there any specific reason? Huh? Because the square root function not defined on left side of 0. 0, that's I mean negative. So we not allow negative quantities in the square root. Am I right? Yes. Also, log function is not defined on left side of 0. Only right side. Remember I draw the graph where the log function only defined the right side of 0. Okay, because arguments are always positive. Okay, that's why it makes sense that we are approaching this function by right side of 0. Okay, good. Step 1, substitute the direct, means make direct substitution and tell me, are we getting any independent form? Which form we are getting when we substitute directly, please? Come on, please. Yes. 0 times infinity. Yes, you're right. 0 square root 0. What is ln 0?
1.
No, it's infinity, yes. Negative infinity, yes, you can write. Okay. So basically it is 0 times infinity. 0 times infinity. Now, 0 times infinity, it is coming in out of 7 forms. Is this a part of out of 7 forms? Yes or no?
Yes.
Because if it is not, you cannot apply the rule, please. Do you have 0 to infinity
Yes.
in this set?
Yes.
Do you have? Oh, yes. So it means this question can be answered by L'Hopital rule. Okay.
Yes.
Right. Now, here is something very interesting piece. If you would like to apply here L'Hopital rule, and definitely because it is one of the 7 forms, it means we can apply here L'Hopital rule, but L'Hopital is required numerator and denominator. The L'Hopital rule says differentiate numerator and differentiate denominator. Do you have up and down functions in this question?
No.
Of course, no. But one thing is confirmed because it is one of the 7 forms which I listed down. So we can apply here L'Hopital rule. But how? So we have to think now. L'Hopital rules require numerator and denominator. Clear?
Yes.
Okay.
But square root does also help.
So we have to rewrite this question in the form of numerator and denominator. And how we write, now this is your skill now, means how you just adjust this function in the format of numerator and denominator, please. So please take a look. You write this one as can you write my question, this question in this form? Please tell me.
Yes.
Yes, why? Because if you simplify this one, you get the same question. Means this divide change to multiply. So 1 by root x will flip, it becomes root x. Yes or no?
Yes.
Means I can write this, my question, in this way. This and that are same. Please don't worry about that. It's the same. Because when you simplify, this divide change to multiply, it will flip. Yes or no? Now, same time, I get my numerator and denominator. But please, again, before we apply L'Hopital rule, we need 2 things. One of the 2 forms, either 0 by 0 or infinity by. So please check, are you getting any one of them so that we can start L'Hopital rule? Sorry, one question is here. Yes, please, please.
Why did we choose the ln x to be numerator?
Yeah, very good question. Very good question. Actually, it depends on the structure of the question. Sometimes when you differentiate, so instead of we are reducing the thing, it becomes expanding. It means our setting is wrong. And there's one more thing. We required 0 over 0 or infinity over infinity. So if means quite possible if you put root x up and lx down, maybe you're not getting. Okay, so but you have asked a good question. Because sometimes both the ways are getting required form, but please, the thing is that when you start differentiating, sometimes the question not becoming reducing, question becomes more complicated. It means our setting is wrong.
Make it x over 1 over x.
Actually, he's asking the same question. That's why. So, if you make this one, please. Example, if you make that root x and divide by 1 and then x. This question can be written in this form, of course. Yes. Now check. Substitute now 0. So this is basically x. How much it is? 0. And divide by 1 over and 0, which is infinity, and we're getting 0 by 0 form. Okay. Here look at it. What is that? Infinity over 1 over 0, which is also infinity. Understand point? Look at here. Both the settings are getting required L'Hopital rule form, right? Okay. Now, which one is correct? Look at here. Now, please, let's check this format, please. What is your numerator, please?
Square root, square.
Where is root x? What is your denominator?
1 over n.
1 over n x. Okay, clear? Actually, this format, when you say 0 by 0 or infinity by infinity, this basically 0 by 0 or infinity by infinity basically confirms your numerator and denominator so that we can take the derivative. So here How much numerator?
Square root.
Please start differentiation.
One over.
One over root x. Understand?
Yes.
Divide by. What is my denominator? 1 over ln x. How I differentiate 1 by ln x? Tell me.
You take,
How I differentiate 1 over ln x?
you take.
I take up. Means I make this one as, I will make this one first of all as ln x and power how much?
-1.
Start now differentiating.
Negative.
Negative sign. ln x. Power how much?
Negative.
-2 time. What is that? Now your function is reducing or complicating. It means this setting is not working.
Can't you derive it as negative in x?
Oh, please.
Oh, like, if you would take the negative, oh, wait, that's powerful.
Come on, okay? So this setting is not working. Yes, please.
In the exam, how can we quickly know that this is right or this is
Oh, that's it. Make practice.
by luck?
No, please, when you take and then start look at it, one step you'll understand, oh, no, it's not working because we differentiate ln power -1, it is going more expansion, not contraction. Now come to this setting, please. Sorry, yes. Yeah, this setting is doesn't work because you asked me why not I write this question in that form, right? Which is also the requirement of 0 by 0, which is valid form. But the thing is that this is not working because when you differentiate, you're not getting answer. The function not going to solve. It becomes more complicated. It's expanding. Now next time, this one becomes 1 over x power 2 times x. So means it is not going to reduce. It is coming to expand. That's why this is not working. Let's try on this one. Okay, come on now, this one. So here, this way. Sorry, one question was sorry. Please.
We take an x -1 up to 1 be positive.
What's that?
Then x to the power -1. It will help. Won't be positive.
My denominator is ln x power -1.
Yeah.
So as per the requirement, I have to differentiate my denominator, please. So logical rules required clearly your numerator function and your denominator function. Very clearly. Okay, so come here now, please. What is your numerator here, please?
ln x.
Very good. And denominator?
1 over square.
1 over root x. And because we need derivative, rewrite 1 by root x as what?
X power.
X power?
One negative.
X power how much?
Negative.
-1. Now start please. Now,
-1.
Negative half.
sorry, -1/2. Correct. Is a square root. Okay. Now, yeah, please.
How will we know that the infinity was 0?
Where? This one?
Yeah.
Substitute 0 here. ln 0 is infinity. Undefined. Check please. You have calculator, please. Okay.
So that's really, it's going to define this.
Yes, yes. Mostly is infinity. Exactly. Okay. Now limit x presumed from right side. What is the nx derivative?
1 over x.
1 over x. Okay, divide by drive x power -1/2.
Negative.
Minus half x power how much?
Half.
Minus 3 over 3 over
This will derive.
power rule n x and -1. So my n is -1/2 and -1 how much? Minus 3 over. Yes or no, please. Okay, good.
Doctor, and this, it's multiplied by 1 also, right?
Yes, so no need right. You're right, you're right. Chain rule times inside there. If it's 1, no need right.
It was 2x.
Oh, yes, then we write, of course. Okay. Now, please, first of all, we simplify and then we go for next step, please. Okay, how I simplify this part, please?
Take,
So this is limit. X approaches 0 from right side. My numerator is 1 by x. And this negative sign, no problem, you can put here now. And this is divide. I have already 1 over 2. Please, this is negative power. I need positive. Put it down.
Take it.
So no, take it down, please.
Take it
So
down.
it becomes. Oh yes, you can do like that. It is fine. So it is 3 over 2. Yeah.
Take it down to 2.
Of course, with 2, it becomes positive now. 3 over. Now look at here, this is divide, and this is 1 over 2 times this one, which is now, let switch please. So what do you get now?
It's 2 and
So limit x approaches to 0 from right side.
-1.
I have -1 by x.
And then
This divide change to multiply. What happened to 2x power how much?
3 over 2.
3 over. Do you understand all of you please? Yes, please. Oh, good. Now, this is, I have minus half. So
No,
minus
just
half.
want the negative, what's your negative?
Oh, please, it's multiply, you put here, 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 no problem, please, doesn't matter, it's multiplication, you can put anywhere, please. Try and tell me, from here to here, you understand?
Yes.
Okay, now we need simplification, why? Because this x has 1 power, and this x has power how much? 3 by 2, so please, this 1 power, take it up,
It will
so
become
it becomes 3 by 2, when 1 goes up,
-1.
-1.
Then after,
So, now look at here, please. Please don't mind. This negative sign is a constant, it's -1. You can take outside the limit, no problem. So the negative sign, limit x up to 0 from right side. I have 2x 3 by this 1 power, take it up. Because what?
you get half.
Express property, please, if you have same, basis, you say that's the same, so you can take the, powers, okay? So how much 3 by 2 minus 1? Half, okay.
To 2 square root.
So now we have negative sign, limit, x approaches to 0 from the right side. 2 times x power, you told me 3 by 2 minus half, half means what?
Square root.
Square root. Now apply limits. Are you getting answer? Yeah, it's 0. What's the answer? 0. And this is a limit of the question.
You have to be sure that you get X.
2?
Then you get X, or it's fine if we stop.
Oh, yeah, means we can write here x power half, no problem. Now put the limit.
I mean, that's it, like, if we stop the
No,
limit.
no, don't stop, please. We need the answer of the limit.
I know, we can substitute.
Can you
Yes.
substitute up?
Oh, yes, it's okay. It's okay. It's okay. It's okay. No problem.
That's it.
But we have to evaluate 3 by 2 minus 1.
Even in the previous system.
E1 in the previous step.
You can
Yes.
substitute.
No, because x is down.
You
It
put
might be
zero.
fine. Yeah. Here, no.
No.
Here, no. Did you do it right? Good. Yes, please. Understand the question? Yeah, come on.
How did the -3 over 2 became positive? Like,
How come positive? Okay.
it was minus, no?
Look at here. It was minus here. What I did, I take it in denominator.
Okay.
I put it down with 2. That's why I move. Right now, it's like that. Look at here. This is 1 over x divided by x power -3 by 2 over 2. This is special. What I did, I shared the denominator here.
Like, in the x, it was in the numerator or the?
Is in the numerator.
No. The x power -3
Is in numerator.
numerator.
Yeah.
So you take it,
Exactly,
With the
I
two.
take it down, look at it. So I have divide, then I have 1 over divide this one. Then this divide change to multiply, it flip. It goes up.
but we don't need to flip the power, like to be 2 over 3.
Oh, no, please, no. Yes, please.
So you do the numerator by denominator and then the denominator, okay. Then it's okay. Like, two fractions, do it. Take it from.
It is up to you. If you feel that format more, easy and understandable to you, you can do it.
Oh.
Okay, so just look where you are more comfortable, that's it.
Okay.
There's no, what I am doing the steps, sometimes it can be do in other ways. No, problems. For example, you learned, the substitution as dx equal. So it's fine, it works, no problem.
Okay.
Okay, sorry, question.
Doctor, if you didn't take the negative outside of the limit, it still gets undefined. So do you have to take it outside? Like, say you put the limit outside to the limit t.
See, limit is a function, same like differentiation, integration. Any constant with a limit you can take outside, no problem. Same like when you have integration, something is multiplied by the constant, you can put outside as a
So
constant.
if you have
During differentiation, if you have constant multiplied, you can take outside the differentiation. Same like limit, you can take the constant outside. Means I can take two outside, no problem. I can write this one as, I can write this one as, yes, I can write as -2 here, yes, it's fine. No worries. Please,
So sorry for this.
no problem, most welcome.
The limit x approaches 0.9, then x power 3/2 minus 1. How? How will?
Okay, do you understand this one, please? I have x power 3, x power 3 divided by x power 4. How is it?
Power 3 minus
Take this 4 up, become -1. Make one variable.
It's right there, right?
Exactly, because I have x down, I have x up. Combine them. So I took this 1 power up, 3/2 minus 1, which basically half. Half means square root, that's it.
What is the negative? Oh, you bring it outside.
Yes, yeah, exactly. I can bring the negative sign outside, no problem.
There is a step I don't understand the previous question.
Previous question. Okay. Which question? Which one, please? Here?
There when we said 1 over cosine, the limit is infinity.
Okay. One cosine. Okay, basically, secant you can write 1 by cosine, yes or no? Okay. What's the x value here? What is cosine pi by 2?
Zero.
Yeah, 0. And 1 by 0?
From right side and the left side, it's different. Positive infinity and negative infinity.
Which one? Which one? No, please. For the infinity part, it's okay. Doesn't matter. Whatever is infinity, positive, negative, no problem. Please. Local rules only require infinity. It's negative, positive, doesn't matter.
Okay.
Okay?
So in this case, we don't count it as non-existent limits.
Yes, exactly. Okay. So I hope you get this question means. So please, sometimes here, it is not the form of fraction. So you have to do the adjustment by yourself to make numerator and denominator. Understand, right? Okay. Let's take one more question, please. Okay, so what is next for the sake of our next required format? No, I just missed one. Five. Six. Okay, let's take one question here. 1 by sine x minus 1 by x. 0 limit. 1 by sine x minus 1 by x. Example 6, please. So we have example number 6. Okay, limit x approaches to 0, 1 by sine x and minus 1 by x. Okay. So step 1, we have, because we need the limit value of this question, substitute directly and check which form you are getting. Yes, please.
over 0
Huh?
plus 1 over 0.
infinity minus.
Infinity minus infinity, yes, because sine 0 is 0, 1 by 0 is infinity, minus 1 by 0 is infinity. So this is infinity minus infinity form. Now please confirm. Is it one of the 7 forms?
Yes.
It is there? Okay, so it means you can answer this question by logical rule, but for logical rules, we need numerator and denominator. Please make the numerator and denominator for this question. Yes, I think we have no other option. First of all, make it here common denominator. Means this part should be multiplied by x. So up and down, please. And this part should be multiplied by sine x, numerator and denominator as well. So please, with this, Common denominator technique, we get now same common denominator. What is the numerator now?
Minus one.
X minus sine. X minus sine. Okay.
Plus.
X and X. Now, before we apply the L'Hopital rule, we need 0 by 0 or infinity by infinity. Please confirm. What we are getting? Substitute 0, please now.
0 by 0.
So 500, it is 0. So my numerator is 0. Okay. Divide by.
Zero.
Oh, yes.
Same thing.
Exactly. So we are getting now 0 by 0 form. It means we can apply L'Hopital rule. Meantime, please, what you have to make sure very clearly, what is your numerator? Yeah, x minus sine x. And denominator?
Sine.
X sine x. Good. Start now differentiation, numerator and denominator. So limit x up to 0, x derivative,
1 minus sine x.
y derivative,
Cosine.
divide by. Differentiate the
We
denominator.
use product rule
Product rule.
Yes.
So
Sine
sine x
plus x.
Cosine
x cosine x. Okay. So we have done, we apply the L'Hopital rule. Substitute again, the x value is 0. What's the answer?
Oh, you get negative one.
Go on, please put here.
Yeah, cosine 0 is 1.
So 1 minus
Minus 1, 0.
0.
So numerator 0 and divide by, yes? Also 0?
Yes.
Oh, again, this is which form? L'Hopital.
Yeah.
We can again differentiate this. So what is my numerator? 1 minus cosine x. And denominator? Sine x plus x cosine x. Please come on. We need one more time differentiation. Limit x up to 0. 1 derivative? 0.
Yes.
Cosine derivative?
So it's positive.
Negative and is negative positive sign. Okay. Divide by.
Cosine x.
Sine is cosine. Good. How I differentiate this part?
Product.
Product rule. So cosine x. And
That's X.
plus change to minus y because when I take the cosine derivative, it gives me what?
Negative.
Negative sign. So please note down this part I differentiate with the help of product rule. UV. Clear? Okay. Now what we can do here?
Now we substitute.
Now you substitute please. Come on.
Okay,
17. What is the answer?
Of 0.
Are you getting undetermined form, undefined form, or some proper answer?
0 over 2.
0 over 2. So
Yeah.
0 over 2. It means answer of
Zero.
0. That's it. We can limit. The limiting value of this function is 0. Form 0. You understand, please?
Yes.
Okay. So basically, I just try to cover, 4 forms without power. Let's start. If you have power forms, how many are there?
3.
3. Which one?
0 to the power of
0 power 0,
infinity to the power of 0.
20 power 0, and 1 raised to power infinity. Okay. Let's take a question from that form, please. Okay. Example number 8. X power 1 by x and x is approaches to infinity. Okay, example 8, x power 1 by x. Example 8, please. Limit when x approaches to positive infinity
And then x to the
and
power
we have
of
x and raised to power 1 by x. Okay. Again, first of all, we have to confirm this limit question, this function is coming from out of these 7 forms, yes or no? Substitute, please. X is infinity, okay? Sorry. So x is infinity. 1 over infinity,
0.
which is basically infinity. What is that?
0.
Is this form is allowed in that list? Yes or no? Infinity power 0 is there or no?
Yes.
Yes. It means this question can be answered by L'Hopital rule. Understand?
Yes.
Now, just please here, the infinite powers they need slightly more calculation, okay? Why? You know why? Because we just finished one, one question in 7.3 when the power is a function.
Which
you know.
to the power sign.
So we need power down, understand?
Yes.
So what we need?
Level both sides.
Okay, now I will give you the steps, all the steps, please. I mean, how you start the question and how you apply L both sides. However, okay, first time I will give the steps, okay? Next time, please, no need for these steps. You can start the question directly to save time.
Using the shortcut, because when it's x to the, as x tends to infinity, do you get the power in it?
You get that?
Power with, that shortcut?
No, please, it's not like that, please. What I mean, so please, this is which case? Infinity power? 0, which is one of the 7 forms, okay, good. It means we can apply here L'Hopital, but please, for L'Hopital, we need 0 by 0 or infinity by infinity. So how we make this form? Please go down, okay. Step 1, let's say the name of my function is y. Let y is x power 1 by x. Step 1, my function is y, okay? Step number 2.
Level both sides.
Oh, yes, apply L both sides, please. And you know very well, when we apply L both sides, this power will be
Down.
come down. So you have now L and Y is equal 1 by x and L x. Okay. Step number 4, please. Apply both sides. Now, limit. Limit, please. Limit. Here, no need to apply limit. Why? Because limit is x approaching. Do you have x left side?
No. It's
So
only one.
limit does not affect this side, please. So this side is no problem. Without limit, no problem, please. So limit x approaches to infinity, we have 1 by x. Sorry. So we have 1 by x and then x. Do you understand until here? Okay, now, what is my suggestion? Next time, please, no need to write 1, 2, 3, these steps. 3 steps, no need. Start your question from here. Because all the questions with power, they have these same steps. So L and Y is equal to, limit and this one, yes. Exactly. Put the power down and like that. So you can avoid these steps, 1, 2, 3. No need for these steps. These steps you can skip. Don't worry. Next question I will tell you directly from here. No need for these steps, please. Okay? Right. Now, please start now. Because this is a limit question and we have to apply L'Hopital rule, right? So we need numerator and we need denominator. I think it's very clear who is numerator and who is the denominator.
Greater than x and denominator x.
Very good. So if you don't mind, I just rewrite this one like that. Means I can write this like that. Ln x divide by. Okay. Now please confirm which form you are getting. We need 0 by 0 or infinity by infinity. Okay. Yes. Ln infinity how much? Divide by. And x is how much? So this is which form? Infinity by infinity. Confirm. Please differentiate numerator, differentiate denominator. Okay, what is my left side? Don't forget, I have an y here. Okay. Please limit x to infinity. What is x derivative?
1 over x.
1 over x. Divide by. What is x derivative?
1.
1. Very good.
It's 1 over x.
Which is 1 by x. If you don't mind, can I just remove this one?
Yes.
Okay. Please apply limits. Wherever you have x, put infinity. What is 1 by infinity? Put 1 infinity, how much? 0. How much 1 by infinity? 0. Okay, good. Be careful. Left side is L and Y. Now we need y value. What we need?
Only one,
Of course, I don't need ln y also. I need y.
but one.
Y means limit. How I remove ln? Basically, the inverse of ln is e. So apply both side e, please. So when you apply this side e, so ln is basically filled. You only have what? Y. And here e power 3,
Just one.
which is 1. Yes. E power 0, how much?
One.
1. So the answer of this question is not 0 basically. E power 0 is basically how much? 1. Do you understand? It is.
Can you repeat the last step?
Actually, look at it. I explained in detail. So we reach here, understand?
Yes, I don't know.
My left side is not y, ln y. I have to cancel a natural log, okay? The inverse of natural log, you know very well, it is base e.
Yes.
So look at here, apply both sides e. So basically this e cancel ln. So you have only from here y. And e equals 0 is that's it. And you do always this step at the end, always in this question.
If it was LN1.
Because it is always ln. Because we cannot answer this question without ln, not possible. Yes, please.
There you go. X over X. Then we got 1 over X.
Because differentiate numerator and differentiate denominator. Lx derivative 1 by ax, and x derivative is basically 1. It is 1, so no one write 1. I hope you understand, it's okay?
Okay.
Good. So I have given an overview of these forms. Let's start the exercise, please. So now, let's go with exercise. I think go 36, maybe 145 is the exercise page number. Maybe 145. Let's check. No, sentence 6. Okay. Right, so these are basically the logarithms rule that guys.
But
At least
when you look as x tends to infinity, can you use that shortcut where you look at the leading coefficients up and down?
but it's not doesn't work here. Yeah, you can check this because most of functions are not rational functions. They are transcendental sine, cosine, ease.
But look at question 12. I think you can use it.
Number 12, yes, you can use, but number 12 actually you can see the
The leading coefficient.
yes, it is 8 by 12, so it is 4 by 3. Yeah, exactly. You can write yes,
Can
yes,
I write this?
but not in all questions.
So if you get this in the
Yes,
exam,
yes,
can
you
use
can.
this.
You can. It's okay. Okay. Now, let's start some questions, please. For example, we can. You can try 22, please. This is limit x minus 1 divided by lx minus sine pi x, okay? 22, please. 22. So x approaches to 1. 22, please. Question 22. So limit x comes to 1.
Excellent.
And we have x minus 1 divided by ln x minus 1. So we have x minus 1 divided by
And then x minus sine by x.
sin x
And then x minus sine by
ln
x.
x minus sine. So it is ln x minus sine pi x, right, please?
So this is question 22.
We do. That's
Okay,
good.
because I'm using the.
Yeah. Right, so please, check please, which form you are getting when you send it directly.
0 over this.
0 over
0 over. Pi, check pi, sine pi, sine 180. I think it's 0.
But how do you know if you're getting 0 or infinity?
No, substitute now. Whenever you have x put 1. 1 minus 1, how much?
-1.
No, 1 minus 1.
0.
0. Divide by. And it is 1, 0. Sine pi 0. So yes, it is 0 over 0 form, no doubt. It is 0 by 0 form. So confirm numerator x minus 1 and denominator ln x minus sine pi x. Okay? Start your differentiation, please. Limit x approaches to 1. What is the derivative of x minus 1? 1. Divide by ln x 1 over x minus sine pi derivative
Cosine.
cosine pi x times pi. Yes. Now substitute limits. Check. What are you getting? Cosine pi. Negative 1. So it means we have the answer. So this is 1 divided by 1 by 1 is 1 and cosine pi is negative 1 become plus 1. So answer is 1 by 2. That's it. Sorry, not negative. I have pi. Sorry. It is basically pi. Pi. So 1 over 1 plus pi. This is the answer. Correct? 1 over 1 plus pi. Yes, please.
Can you repeat the derivative minus sine pi x?
Actually, ln x 1 by x. And now we have differentiate this one. Sine function. So sine, there is cosine, multiply angle derivative. So angle has a constant which is pi, keep as it is, and x derivative 1. Chain rule. So now when you substitute here x has 1, you have cosine pi. Cosine pi is negative 1. Negative 1 and this negative become positive and you have pi as it is. So limit is this one. 1 over 1 plus pi. Please, any question?
How do you cosine pi times 1 in the?
No, please see. Now x is 1. So please just put here pi times 1. So it is pi. Cosine pi how much? Negative 1. So negative 1 times pi and this negative becomes positive pi. Okay, I think you have some confusion. I just write for you again. Look at me, please. Just look at here. Now this is 1 divided by x is 1, okay? Minus cosine pi times 1 times pi. This pi is multiplying. This pi is not the angle, please. So pi times 1 is pi, cosine pi. This is giving you negative 1. This negative, that will become what?
Positive.
Positive.
So negative
yes.
pi sine.
So 1 plus, this is finished now. So 1 plus pi. Okay? Because the answer of this one is negative 1, okay? That's why, please. So this is 1 over 1 plus pi. Right, okay, please. Take any one more question, please. Can you go with 32? Please check. 32, please. You can try now, please. 32. 3 power x minus 1 divided by 2 power x minus 1. And limit is 1, 0. It is 0 over 0. Good. So if it is 0 over 0, so you can differentiate the numerator and denominator. However, the numerator is not base E. So you have to convert, change, first of all, base E. And then differentiate these. Both of them, yes. Thank you. Which question? 32, please. 32, please. Try this one, please.
We know that denominator is not the base.
First is 2 power and 3 power, not e power.
So
First of all, please check, are we getting any required form of logarithm?
yes, it's 0 over 0.
It is 0 over 0, good. Then, if it is 0 over 0, you need differentiation.
Yes.
But unfortunately, you cannot differentiate because it is a power x function.
The power function. So we need to.
Is exponential function with power with the base a, not e.
A.
Yeah, first change into e. Yes.
So we need to put
How we change a power x to e?
don't need to put like an on both sides.
No, please, don't confuse yourself, please.
Into the power of x and a.
E power x and then 3. Yeah. So e power x and then 3.
It's
And then 3, yeah. So it's 32 question, please. So limit we have x approaches to 0. 3 power x minus 1 divided by 2 power x.
Yes.
Yeah. Okay. So now, if you substitute here 0, 3 power 0, how much? No, 1. So 1 minus 1, 0. Divide by 2 power 0 is 1. Yeah, so basically it is 0 over 0 form, correct? Okay. Now we have differentiate, but we cannot differentiate base A. So first of all, convert into base E. So limit x up to 0. 3 power x we can write. And then 3 minus 1 divide by
Over e power x and then
and 2 minus.
1.
Now start differentiating. So now limit x up to 0. Derivative of ex ln 3 is
Ax ln 3 times the derivative of the
ln 3. 1 is constant, 0.
Yeah.
Divide by e power x ln 2 times ln 2. And definitely because this is constant, 0. Now please substitute. So wherever you have x, put 0. So e power 0, how much? 1 times ln 3. So in numerator, I have got ln 3 divided by e power 0, 1.
ln 3 calculate.
No need, please, because x is 0, 0 times ln 2 is 0. E power 0 is 1. E power 0 is 1. So answer is how much? ln 3 over ln 2. That's it. We have got the limit answer. Okay? Right.
Doctor, can you repeat?
And this one, please.
That's the
Do you understand how we change?
function.
Okay, now differentiate. So what is the derivative of e power x? Copy paste same function times power derivative. So in the power we have ln 3 which is constant. So as it is, no need to change, and x derivative is 1. Same we have done in the denominator, please. Copy paste same function of e times exponent derivative. Clear?
Yeah.
And then we substitute limits. Wherever we have x, we put 0. So e power 0 is 1. So you have only ln 3 in numerator. Same thing. E power 0 is 1. And we have ln 2. Okay? Good.
So, it's like e power 0, you said it's 1. What about the ln 3? Like,
No, e power 0 is 1. So 1 times ln 3. Because ln 3 has no x. X is 0 now.
1 times ln 3, it's ln 3.
Yes, so ln 3.
I thought it's a difference of this from the ln 3.
Where?
We
E?
substituted the x with 0, right?
Yes.
Which is 1.
How? Because e power 0 times ln 3 is 0. 0 times ln 3 is 0. So it becomes e power 0. Now it means with 0, you're going to look at here. Now it becomes now like that.
For 0.
How much?
One.
One and 3. That's okay?
We simplify more and put LOG base 2.
No, please don't. Stop here is the answer. Finish. Don't make your life in trouble, okay? Don't even. Right, because the constant is number. That's reading the answer. Okay. Right. Let's take some few more questions, please, before we start the powers question. It's okay, it's okay. We can go to power, it's fine. So one of the questions power I have done as example 8. Now, let's start this. Okay. Right. 63 questions, please. Come on, 63. Analyze history and check which format you are getting, please. 63, please.
Power infinity. The power would be infinity.
Yeah, okay, just check this. 63 question, please.
How do you apply
Go check this.
infinity to the power of infinity?
For one,
Infinity for infinity. Is there any form?
it's one power.
Infinity to the power of
One power.
Yeah.
For infinity.
Huh?
One for infinity.
Yes, it is one power infinity. Exactly. 63 question is basically one power infinity. Do you know?
How did we get the one?
Ah, yeah. So, you understand that this is 1.3? Yes or no, you understand? Yeah.
Infinity over infinity.
No, actually, it is not infinity. Basically, try to, find its impact. X is opposed to what?
Infinity.
Infinity, X is very large, big. Okay, do one thing, please. Hold your calculator, please. Put here X as 10 power 5. 10 power 5 plus 2, 10 power 5 minus 1. Come on. Because we are making X very, very large, okay? So check this, huh? 10 power 5 plus 2 divided by 10 power 5 minus 1. Huh? 1.0, 0, okay. Raise more. 10 power 10 plus 2 divided by 10 power 10 minus 1. Now, take one next value.
One.
Huh?
one.
That's it. Now understand? So basically, this portion is going towards what? Approaches to 1. Very good. And X is how much? So 1 power infinity. So it's very clear. 63 question is the case number 1 power infinity. Now you agree? Yes or no?
What to prevent the power larger?
Yeah, that's why you're getting 1 because you're making up and
No,
down.
I mean more than 10. I put, for example,
10, okay, put 10 power 20 or 10 power 20. 10 power 20 plus 2 divided by 10 20 minus 1.
You get one.
I put 1000.
Is working?
No, once.
No, it's not working because the memory is very, very less. But you understand it's going to 1. Yes or no, please?
Yes.
Good. So 63 question is basically, it is 1 power infinity. Okay.
But it's power 20, it's one exact.
See? Exactly. So question number 63, please. Limit x up to infinity,
X plus 2,
x plus 2 divided by
X minus 1.
and power x. And I just explained to you, it is which case? 1 power? And this is one of the 7 powers. Yes or no? Very good. It means we can apply here L'Hopital rule. But because it's a power case, and I explained one example to you, it has some steps in the starting. Just skip all the steps. Start with this one. Look at it here. And then y is equal to power can come down. X limit x approaches to infinity. You have now x plus 2 divided by x minus 1. You understand it? Okay. Now here, we have to, make the numerator and denominator so that we can go with this I'm sorry, I just forget this one. Alan, sorry, Alan.
How we should put
Okay?
Do we use professional?
No, please, I apply both side Alan, please. I apply both side Alan, please.
Then you break it down?
No, see, the power come down before Alan, look at here. I apply both side Alan, then X comes down before Alan.
Yeah, I mean cushion property.
Oh, means after that?
Yeah.
Okay, just wait. So now we have here, sorry. This is X, and then this one, and limit now. X approaches to what? Zero, sorry, infinity. Okay. Now, because we need now numerator and denominator. So what do you think?
E both sides.
No, please, I need the limit value. I have to apply local rule.
Only for X minus.
So I need numerator and denominator for the purpose of differentiation. So make some adjustment. How I write this, question in numerator and denominator.
And have one of it.
Okay. So please, just write limit X up to infinity. Now, I can write this one, means my this term, please. This is my question now. I can write this question like that, please. Ln with the argument x plus 2 over x minus 1
Over one over.
divide by 1 by.
Will it be negative? Then let's take it down.
No, please, I rewrite this one like that. You simplify, you go back. Yes or no? I can write this question in that form because we did this before as well. This x I can write 1 by y because this divide change to multiply 1 by x become flip becomes go back here. Yes, please.
like we couldn't just find the derivative of the.
No. You need numerator, you need denominator first.
So that
Where?
x plus 2 over.
No, it's one function, it's an element function, please.
So figure.
It's one altogether, exactly. Now you understand? Very nice. Now check. This is 0 by 0 or infinity by infinity, please. It is very important, please. Tell me.
0 by 0.
So you know very well that when x is up to infinity, this part becoming 1, am I right? So it is ln 1. How much ln 1? 0. And divide by 1 infinity, how much? 0. So please, it is very clear now. What is numerator? How much numerator? Numerator. Ln x plus 2 by x minus 1. And denominator?
1 over.
1 over x. Again, I'm asking, please, do you know how we get up 0? How we get up 0?
And then 1.
Because it is going towards 1. Because when you make this x very, very large, it's going to 1. And ln 1 is how much? 0. That's why in numerator we are getting 0. Okay, now it's time to differentiate. So, for the purpose of differentiation, now it's your choice. And I think for differentiation, please use the property now so that our differentiation becomes easy. Otherwise, when you go without property of log, you say 1 over argument times argument derivative. When you say argument derivative, you need which rule? Quotient. So it becomes very complicated. So before to start derivative, please use the log property, please. How I can use the log property, please? Sorry. So limit x approaches to infinity. This one I write how? Ln x plus 2.
Minus x minus.
Yes, ln x plus 2 minus ln x minus 1. Very good. And this is 1 over x. Please, I use the log property to make it subtraction. Is possible? Yes or no? Good. Oh, now you can differentiate. Now it's easy to differentiate this. So now limit x approaches to infinity. Yes, please. What is
Over x
1 over x plus 2?
minus 1 over
Okay.
x.
Minus 1 over x minus? Very good. Divide by, what is 1 by x derivative?
Negative 1 over x.
Negative 1 over x square. Use the shortcuts, please. That's it. Write directly, please. I differentiate numerator. I differentiated denominator. 1 by x derivative is minus 1 by x square. I hope all of you understand. Very good. I need simplification first. What we can do for simplification?
Common denominator.
Common denominator. Very nice. So this part should be multiplied by x minus 1. Also up, also down. Understand?
Yes, like this.
This part should be multiplied by x plus 2 and also here x plus 2. So for the sake of common denominator, please. We are here now. This is limit x approaches to cos infinity now. Okay, I have now common denominator. What is that?
X plus 2x.
X minus 1 and x plus 2. Okay, good. And in numerator, I have what?
X minus.
X minus 1
Minus x.
minus x and minus 2 because outside is minus. And please, when you say divide by minus 1 by x square, if you don't mind, can I flip the answer?
Yes.
Times negative x squared over 1. What do you think? What do you think, please?
The negative.
This divide, I change to multiply. 1 by x squared becomes x squared by 1.
And the negative is gone because.
No, it's not gone. Please, the negative is here. Next sign, this next sign is here, please. Okay, don't remove the sign, please. Okay, now this and this cancel out. Very good. Minus 1 and minus 2,
Negative.
negative 3 times negative 3. So 3 and 3x squared. So now finally, in a simplified form, what we are getting here now, limit x approaches to infinity. Look at here. Negative minus 1, negative minus 3 times positive 3x squared. So in the numerator, I have 3x squared. Divide by x minus 1 times, please expand, multiply. X squared minus x minus minus x
2x.
plus 2x and minus 2 plus x, right? And negative 2, yes.
But
I
can you
multiply these two.
Can you keep it?
It's okay, actually, why I multiplying, because for me, now it's very easy to get the limit. Shortcut. Up and down, degree are same,
Yes.
so take only
So
coefficient.
3/1.
So 3 over 1, so limit is how much?
3.
3. What's the limit answer? Please, I did not use the differentiation. I use shortcut. You know very well, if limit is on infinity, the shortcut is that if up and down degree are same, only take the leading coefficients.
Same.
Yes, so x scale coefficient 3 here. Down x scale coefficient is 1, 3 over 1, which is why is that 3. Okay, my question is that. Is answer?
No, then 1.
It's not the answer. Why? Because other side is what?
So the calculate the same answer by.
By the derivative.
Yeah.
Yes, same answer. Drive up, 6x. Drive down, 2x plus 1. Again drive, 3 divided by 1. Same answer, okay? So please, my other side is L y. So please give my ln y is equal to 3. We don't need L y, we need y only. So what is y? E power? This is the way to answer the question of power, please.
Was it the negative?
Sorry,
Was it supposed to be negative 3?
this one?
Yeah.
Minus 1, minus 2, how much? Minus 3 times negative. So positive 3. Okay.
Doctor, we remove the denominator by having the leading coefficient.
Yes. By take the short story, exactly. So, but other side is ln(y), so we have other side is ln(y) is 3. Remove ln by e, so answer is y is equal to e power 3.
And one last question. Where did the minus come from?
This negative?
Yes.
Oh, this negative comes from here when you differentiate 1 by x. So derivative 1 by x is minus 1 by x squared.
Yes.
1 by x derivative is minus 1 by x squared.
Yes.
So this negative sign is still with you. And then this divide, then again divide, you flip, it becomes x squared by 1.
Becomes
But don't remove negative sign, it is here.
when we flip, shouldn't the sign change?
So sign change for the power, not for the multiplier.
Only power.
We have means, for example, you are here, for example, look at here, you have x power minus 3 over x power minus 4 is. When you move this up and down, means move x power minus 4 up, it becomes x power 4 positive. And you move this down, so if you move up and down, then these sign change, power sign change, not the multiplier. This, if it has negative sign, it still has negative sign.
Should remain.
It remains, yes. Understand now, please?
Sir, can you just show the final piece?
Okay, so this is basically because my left side is ln(y). We need not ln(y), we need y. So remove ln by taking p both sides. Understand, please? Okay.
So that's it.
One last question from this topic, but
5 minutes, sir.
okay, at least you can try this question. Then, because only one last question which I have to discuss with you, because it has slightly different formats. No, sorry, not different format. Oh yes, it's a good thing because we have discussed already. Okay. Please look at it. The last two questions, 67 and 68, same pattern question. I will answer 68. You can answer it by yourself. 68 please. Sin x, ln x. Limit is 0, right sign. Okay. So 68 question, please. And the concept you know very well already because I discussed with you already this part. 68. Limit x to 0 from right side. It has sin x and ln x. Okay. Which case is that? 0 times infinity. Yes. This is basically 0 times infinity. All of you understand? Yes or no? It is 0 times infinity case.
Yes.
Clear or no? Because sin 0, 0, ln 0, infinity. This is 0 times infinity. Is this a form of self forms? Yes, good. It means we can apply here law below rule. We need numerator and denominator. So please give me the adjustment. And that's it. This is the only story which you need. How to make adjustment. We need numerator and we need denominator.
Over secant.
Huh?
Over secant.
Yes, exactly. ln divide by 1 over sine, which can be write as cosecant. Okay? So means I can write this question like that. Look at it. Because I need numerator and I need denominator. So limit x up to 0 from the right side. This one I can write ln x divide by 1 over sine. Can I write this question like that?
Yes, sir.
Because when you simplify, flip, you go back to your original question. There's no change in the question by the way. It's only the structure to write the question, okay? Check. ln 0, how much? Infinity. 1 over 0. So basically, it is infinity over infinity case. Agreed? Yes or no?
Yes.
Okay, good. So when you check it is infinity or infinity case, please tell me what is my numerator? Very good. ln x. What is my denominator? 1 was sin x. Can I write 1 was sin as cosecant so that for the purpose of derivative becomes easy for me? Okay. So please, it's very clear. My denominator is 1 by sine. I can write 1 by sine in another simple way. And what is that? What is that? Cosecant x. So please start now with the root means differentiate numerator, differentiate denominator. Come on, please. So I have now limit x up to 0 from right side. What is x derivative? 1 over x. Divide by cosecant derivative.
Minus
Negative cosecant x and cosecant. Okay, good. Now again, before we start further, we need simplification first, so that we can get a very clear picture of our next, format. So first of all, like to simplify this. Then we take next step. Limit x up to 0 from right side. Okay, 1 by x. Okay, divide by this negative sign. No worries. You can put something here. Yeah, here you can no problem, please. Cosecant is what? 1 by sine. Cotangent how much?
Cosine over sine.
Cosine over sine. Okay, good. Very nice. Now look at here. If I combine this one, I get cosine over sine squared, right? Can I do here the same step, please?
Yes.
If you don't mind. So I have cosine and divide by
Science.
sine squared. Divide by what?
Science.
Very good. This is divide. Then again divide. What happens? If I change divide to multiply, it will flip. So what? Sine square over
X minus.
cosine x. Yeah.
X.
X cosine x. Yes, yes. Good.
Sorry.
So limit x up to 0 from right side. Sine square goes up. Don't forget the negative sign. It becomes sine square x and divide by what? X time
Science.
cosine x. Please tell me from here to here. You understand what I mean?
Why did you take x down?
No, we don't take x down. X is already down. Only this is times it please.
Okay, so it went down.
Because
Yes.
x is multiplied with the cosine x, and the sine square x is multiplied with the 1.
Yes. Exactly. Yes, you're right. And did I hear any question? Is clear? Okay, good. Now here, please. Actually, the thing is that we can go further, differentiation takes time. Let's take one property which we learned in Calculus 1. Huh?
One.
Science squared. Science squared.
No.
Is it the one minus cosine square?
No, please, for limit purpose.
Sine square is equal to sine square.
Anybody knows this? Huh?
It's fine. X
Sine.
over x is.
Sine x over x. If limit is on 0, how much answer?
One.
1. So please look at here. This sine square, actually, I don't want to do this sine square, but because maybe you get confusion, that's why I make it square. Because now, can I write sine square again like that? Means sine x and again sine x. Yes or no? Okay. Now look at here. Sine x over x. And limit is on 0. What's the answer?
One.
You know this property?
Yes.
In Calculus 1, chapter 2, section 2.4. Okay, so you're using here sine x because if angle or denominator are same, limit is on 0, it is 1. Remember or no?
It's only if the limit is 0.
This property only works if limit is on 0. Yes. So please tell me after using this property, it becomes 1. What are left over? Sine divided by cosine.
Which is
And we have negative sign. So sine or cosine, how much?
that.
Very good. 10. So limit x up to 0 from right side. This negative sign put outside limit. Sine by cosine is tangent. Please apply limits. What is tan 0?
Second.
Zero.
Tan 0 is 0. We get the answer of the limit. That's all. This one. Sine by cosine, how much? Tangent. Negative sign is as it is. Apply limits. Wherever you have x put 0. So tan 0, 0. Hope you understand. Please, same pattern, the question is,
57.
67.
67.
Try yourself, please. The same pattern question, please. Okay? Okay, please? Good. And that's all. We have done 7.5 as well. Next, that shall we go for 7.6, please?
But what is the last section in chapter 7?
7.7. Two more sections.